The reason we would be sketching is because good mathematicians think in pictures. We see the problem, we see the algebra as a picture, and then we see a route through the problem using the picture in our head, and then we use the algebra to actually solve the problem, but we're always thinking in pictures. So it's really, really important to develop this skill. I'm going to number these steps and then we'll go through them in turn. We're going to start by putting the roots on an x-axis. Okay, so we're going to start like this, which may seem a bit weird, but bear with me, this does work. And we're going to put the roots on this x-axis. Okay, then we're going to determine the start and end quadrants for the graph. And I'll explain what that means in a minute. We're going to classify the root types. There's 3 types. Add a y-axis right at the end, and then put that y-intercept on. So let's talk through what's actually going on here. We've got 3 factors. Each factor corresponds to a root. So we've got this factor here, 4 minus x. If that's 0, then x is 4. We've got the factor x minus 1. If that's 0, then x is 1. And we've got the factor 2 plus x. And if that's 0, then x is minus 2. So we've got these 3 roots. Now I'm going to put them on this x-axis, doing number 1. I'm going to not be too fussy. I'm not going to get a ruler out, but I'm going to have a rough sense of distance. So let's say that this is 1, 2, 3, 4, 1, 0, minus 1, minus 2, something like that. Okay, this root, 4, he's all the way over there. They're not in the order that they are on the x-axis. And then here's 1, and then here's minus 2. Okay, now 4 is a single root. There's no power. Oh, I meant to have a squared. Yes, I meant to have a squared on there, sorry, put the squared on. 4 minus x, this root here, this is a single root. There's no power on that bracket. So this is a single root, and what that does is to slice through the axis. Okay, so this is going to slice. What about this one here? Well, this one is cubed. A cubed, or any odd power, any even power here, any odd power here. If it's an odd power, then you're going to get an inflection. And an inflection is where it comes up and touches as if it's going to turn and go back down, but then it actually goes up, or the other way around. So that's what an inflection point looks like. So this one's triple, and that's an inflection. And then finally, minus 2, that's a double root. It's squared, the factor is squared, and a double root is a touching root. So that goes like that, and touches all the other way up. Okay, so now we know what they're going to look like. We're going to have something that looks like that, something that looks like this, and something that looks like that. Before we put those on, let's determine the start and end quadrants. Now, if you have an odd powered polynomial, so that's the biggest power is odd, then you've got 2 possibilities. Either it starts up here, and it, I don't know, wiggles around, does some stuff, but it ends up going down there. And that's a negative odd polynomial. Or we could have a positive one. That starts down here, and it goes up, wiggles around, wiggle, 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 stuff, 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 and then up it goes up there, and that's a positive one. So in both cases, if this is odd, it's the graph goes from above to below or below to above. If you have an even power as your biggest power, then you've got either a negative situation, which it starts down here and finishes down here. That might do anything in the middle, depends on the power, and that's what a negative one would look like. And a positive one would start at the top and end at the top. Okay, so that's odd and that's even. So we can look at our polynomial here and see what that largest power would be. So if it was expanded, the largest power would be, well, we've got squared here, cubed here, and 1 there, 3, 4, 5, 6. So that's even. So either the graph's going to start up here and finish up here, or start down here and finish down here, depending on whether it's a positive or a negative polynomial. Okay, the way we can tell if it's positive or negative is if it was expanded, what would the coefficient of that x to the 6 be? Positive or negative? Okay, well, here we'd get positive x squared, here we'd get a positive x cubed, and here we'd have a negative x. So all together, it would be negative. So we've got an even power and a negative function, or a negative polynomial, not negative as in it's always down here, negative as in it's upside down. So it's going to start down here and it's going to finish over here. Now, we've almost finished now. We've basically done all the thinking that we need to do. We just need to literally join those dots up. So we're going to sketch. Now that we've classified them, we know where it's going to start and end. We can just go ahead and sketch. So we'll go up towards this 2. That's going to be a touch. Okay, now I'm going to go towards the 1. The 1 is going to be an inflection. And to draw an inflection, I draw what looks like it's going to be a touch, but then it actually goes up. So it's a little tip there for an inflection point to look good. Then a tip is to draw what looks like a negative quadratic. It looks like it's going to go down again. And then I actually take my pen off and go back again and then draw what looks like a positive quadratic. And you're looking for that stationary point there. So there's a moment where the derivative goes flat and then off it goes up again. So there's a point of inflection going up like this. And then 4, that was a slice. So at some point it's going to turn, then it's going to go down and it's just going to slice through that 4 like this. Okay, now I can put a y-axis on. Where would the y-axis be? About here. I didn't want it cluttering up my picture and confusing me. There's the y-axis. And now I can do the y-intercept by putting x is 0 into here. And I would get y is 4 minus 0, 0 minus 1 cubed, 2 plus 0 squared, minus, no, 2 times 2 isn't 2, it's 4, minus 16. So this is minus 16. Okay. I hope that looks relatively straightforward. Once you get practicing with it, you'll find it really straightforward, I'm sure. I do want to point out a very, very common mistake, which is that turning points do not necessarily live on the y-axis. And that is why they might live on the y-axis, but they probably don't. And that is why I've got this y-axis tucked right at the end, not getting in the way. Students who draw the y-axis on at the beginning, what happens is, and I do not know why in all the years I've been teaching, what happens is that there are 2 strategies that students use. So they have the y-axis like this. And let's say they were sketching a quadratic and it was going through -1 and 7. Strategy 1, put -1 and 7 equal distance from the origin, and then you can force that turning point onto the origin. Strategy 2 that students use, they do actually get the -1 and the 7 the right sort of distance away, but for some reason the brain just loves this turning on the axis thing, so then they draw it like that. Okay, so these are the most common mistakes that we see with sketching factorised polynomials, is for some reason these turning points get yanked onto the y-axis and then the turning point is not in the right quadrant. Like here, it should be to the left of the y-axis, and then your shape is wrong and then you're losing marks.